Hello, everybody. Thanks for joining us and welcome to Raycastle's latest live webinar, Financing the Change from GSM-R to FRMCS. Now, the transition from GSM-R to FRMCS, the Future Railway Mobile Communication System, is a critical step forward in modernizing railway communications, ensuring enhanced efficiency, safety, and interoperability across networks. However, financing the transformation presents significant challenges requiring strategic planning, investment, and collaboration amongst stakeholders. In this webinar, you'll gain insights into the financial considerations of this shift, potential funding models, the cost implications, and the best practices for securing investment. Now, our speaker today is Andrew White. He's the CEO at Raycastle. He's held numerous executive roles within the telecoms industry across the globe over the past 35 years. He's a fellow of the Institute of Engineering Technology, was awarded a Master's in Electronic Engineering from the University of Surrey and an MBA from the London Business School. Now, before I hand over to Andrew, just a couple of small housekeeping bits. Can you please ensure that you keep your microphones muted throughout the presentation? If you have any questions, please pop them into the chat box and Andrew will answer them at the end of the session. Just remind you that a copy of the recording of the webinar will be sent to all those who registered at the end of the webinar. But that's it for me now, so I'll hand over to Andrew for the presentation. Over to you, Andrew.
Thank you, Paul, and good morning, everyone. And welcome to this webinar where we're going to discuss the financing options of the migration from GSM-R to FRMCS. Unusually for a Raycastle webinar, this webinar is brought to you by Raycastle Consulting, which is a member of the Raycastle Group. And just as a little bit of an introduction, or by way of introduction to Raycastle Consulting, the consulting arm tends to deal with more consulting style projects rather than training, of course. The projects tend to be in critical infrastructure. So there's a few examples of the projects here. And as I've sort of reviewed them in preparation for this webinar, it's surprising actually how many of them relate to fibre of one way and another, whether it's an FTTH project, whether it's a subsea project, or indeed whether it's an FTTT, which is fibre to the tower. And normally the projects involve either dark fibre and civil works and working out the economics of a business that's looking to do that, and the geospatial planning and building of that, or indeed whether it's a lit fibre project. So, for example, the FTTH project for 600,000 homes was a lit fibre project, and we were working out the economics of the business case there in that particular case. So they're all sort of really sort of heavy critical infrastructure, telecommunications infrastructure projects that we've done within consulting over the last few years. They're all jolly interesting, and for any of you that may be interested in some of those points, please connect after the webinar. A little bit about my background. Paul's given a brief introduction, but I guess the key thing and the key takeaway here is that I've spent 35 years in the telecoms industry and come from the telecoms industry perspective to this topic. That's very important when you think about, rail and telecoms working together. You'll understand that Andrew's experience comes from the telecommunications industry, although obviously I've been working closely with the rail industry over the last 3 or so years, and have got a very sort of interesting blend of the different requirements between the two, and we'll come to some of those differences and indeed similarities as we go through this presentation. Okay. Many of you will know that Raycastle powers the UIC Rail Academy. And I just want to make it clear at this point that Raycastle Consulting and Raycastle Limited are part of Raycastle Group, but I just want to make it very clear that the opinions and views that we may express and points we raise here are not necessarily endorsed by the UIC. So just want to make that clear, please don't go back to the UIC and say Andrew said, because indeed it may be an opinion, they may agree with it, they may not as well. So there's no coordination between Raycastle and the UIC on this particular topic. Okay. Along with the link to the recording of this webinar, Paul will send out a copy of a white paper that we've written and published on this topic. It explores the topic that we're going to go through. It's aimed at raising the awareness of the challenges that the industry is going to face in the migration between GSM-R and FRMCS. How's it going to be funded? It explores the options. We are not at a stage in this migration where there are clear answers at the moment. It's really exploring challenges and raising those challenges. So as an industry, we can all start thinking about those issues. Situations are different. Everyone's situation is different. Every country's situation is different. Therefore, the outcomes are likely to be different. However, we also need, as a community, to understand which of those decisions that we may be making in one country will actually have a serious knock-on impact and implication in another country. Because, of course, FRMCS is a pan-geography solution. So we need to ensure that we've thought through all of those possibilities and make sure that they are aligned. And we'll talk about what some of those issues are as we go through the presentation. Okay. So just as a summary, we're here talking about challenges and not really giving answers at this point. These are things that we need to all explore. Okay, when we have a look at the similarities between the rail industry and the telecommunications industry, and personally, this is the first time that I did this about 6 months or so ago, and it's very interesting when you step back and you think, so how similar are these two industries and how different are they? And very surprisingly for me, and this is looking at it, I did this analysis on from a UK perspective. The information was easy for me to obtain. If you look at the UK revenue of the rail industry, it's about 10.3 billion. UK revenue from the telecommunications industry, very similar, same order of magnitude, about 14 billion. I understand everyone's here thinking, 4 billion is a lot of money. I understand that, but from an order of magnitude, it's very similar. The references can be found in the white paper that's on our website, or we'll send around after the webinar. So if you want to check where I got the information from, you're able to using those references. Both industries are capital intensive. Okay, it's pretty obvious, but both rail and telecommunications highly capital intensive. Then when you think about the differences, the rail industry is largely a public sector type industry. The infrastructure managers are mainly state-owned. In the telecoms industry, it's pretty much private sector. As we all know, major telecommunications networks, the so-called state incumbents, were privatized in the 80s and 90s. Pretty much all of the mobile operators are private sector. So that's a key difference between the two industries. Second key difference, in my view, is the focus on the safety criticality. In the rail industry, hundreds of thousands, if not millions of members of the travelling public's safety is put in the hands of the rail organisations on a daily basis. That's very unlike the telecommunications industry, where for a normal commercial telco, I've been racking my brains and I can't find a safety critical application that a telco offers. And this is for a normal commercial telco. I've not been able to find one. There may be some military circuits, for example, that a telco will offer, but they're highly unlikely to be safety critical. And where they are, there's typically layers of redundancy that the customer lays on top. And even in that case, if the communications is really safety critical, if it fails, the end application will stop in a safe manner. So I'm interested if anyone does know of a safety critical telecommunications application to send through to me afterwards, because to me, it tends to be graceful failure rather than a real safety critical type arrangement. So that's a key difference to me between the two industries. Now, if we talk about also thinking about the upgrade that's required, the upgrade between, effectively, it's a 5G upgrade we're talking about here. The estimates for the telecommunications industry for its 5G upgrade for the UK, as referenced by Ofcom, is between 11 and 40 billion euros. The reference will give it to you in sterling, but I've converted it to euros. You can see that's a very large number, and that's simply for one country. Our estimate for the upgrade for FRMCS in the UK is between about 1 and 2 billion euros. This is our estimate. It's not terribly scientific at the moment. It's just an approximate order of magnitude. But if you get the idea here, the capital intensity of the telecommunications industry and the upgrade that they're requiring is an awful lot more than that to upgrade the telecoms on the rail network. Obviously, the telecoms industry covers a larger geography. The FRMCS upgrade only covers the track as such. But one key takeaway from this, if you look at it across Europe, the FRMCS upgrade is likely to be what? In the order of 20 billion, something like that, across multiple countries. So it's a big number that we're talking about here. So on number one, we've got a large number. Number two, when are we likely to see and need to deploy this number? For those of you who've been following the FRMCS project at the moment, you'll know that the current state of play is that we're starting, or the industry's starting, what's called MORAN 2 trials, where they're taking equipment and trialing it on a number of high-speed and low-speed lines to work out how the technology actually works in practice. The outcome of this is that there's likely to be commercial equipment available to be deployed at the end of 2027, beginning of 2028. And it's likely in preparation for the deployment of that equipment that infrastructure managers will be upgrading their tower estate, their physical infrastructure in the late 2026, early 2027 zone. So in other words, they're spending hard money at that point in order to deploy and have active service in maybe 2028, something of that sort. So that's just to give a time frame of when the spend is occurring. And that's relevant when we bring those two things together. We see that the funding that we need here is large and it's soon. So with that in mind, the focus of the white paper that we've written is ultimately around the thoughts and ideas of how we can turn FRMCS from a pure cost center into a profit center. Thoughts along those lines. How can we do it? How can we turn this from just a pit where we have to spend a lot of money into an area where we can actually bring in, get some income in, some revenue flow to subsidize that cost? What are the options? Okay, so how are we going to fund FRMCS? Well, the simplest option is simply to go to the public paymaster and say, I need 1, 2, 3, 4, whatever the number is, billion to deploy FRMCS in my country, within my rail network. I mean, this is the luxury option. If you have this luxury and you absolutely know that your public paymaster is going to pay for it, you might be tempted to disconnect from this webinar right now. Okay, you may be tempted to do it. I would just ask you to hesitate just before you press the disconnect button, because of course, one of your fellow listeners here may also actually be the public paymaster. And of course, you may be asked to justify why aren't you doing like they're doing in another country? Because I'm sure that many countries will be looking at this thinking, how can we turn this into a little bit of a profit center? And equally, you may just have the uneducated asking you similar questions. So let's go through what the options are. Okay. One popular option that I've heard many people talking about is the idea that this could be simply subcontracted to the private sector. Okay, so what do we mean by that? Well, ultimately, it's some form of what in the telecommunications industry is known as active sharing. So, for example, it could be network slicing, for example, where an existing mobile operator that's running a network in a 5G network, they're able to configure that network such that a slice of it is used for a different purpose. For example, a slice could be just for FRMCS. You could bring your spectrum, etc., and the commercial operator could light that up for you. That obviously brings the benefits of economies of scale from the private sector organizations, competition of supply. For a private sector mobile operator, it may be a very interesting business case where they can make some additional revenue and some additional usage on their infrastructure. Okay, those are all that's basically what it is and the positives of doing it. Now, there are questions, however, over whether the private sector has enough coverage to cover the rail network. In some countries, it may well have. It could well be done, and it may be possible to do this. In other countries, certainly in some countries where I've traveled on the trains, the mobile coverage isn't that great, and you do wonder whether there's enough coverage and whether there's a business case there for the private sector companies to actually need to deploy that extra infrastructure in order to provide this type of solution. The other area that I think is very important when you consider subcontracting this service to the private sector is the safety criticality culture within the two industries. The rail industry clearly has a safety first culture. The telecommunications industry, in my experience, has had less need to do that, and therefore the safety criticality of the service that it offers is not, there isn't such a culture within the organization. It's not to say that there isn't a safety culture per se for people doing rigging and that type of thing. Of course, there is within the industry. But when we're talking about the service here, that's not something that I've experienced in my time in the industry. So it's a key difference. Not to say that it can't be done, but I have to say that writing a contract and an SLA regarding safety criticality and actually delivering it from a cultural perspective, in my view, is different. And you know, if I was responsible for people's safety, I'd certainly want to make sure that I had something more than just a paper SLA, for example. And this is something that I think really needs to be considered when looking at subcontracting the problem to the private sector, but can be done. And if you're happy with it, certainly it's a workable solution. Okay. Another alternative is passive sharing. And that's where effectively you say, well, okay, I've got a bunch of towers and physical assets that I'm currently using in the rail industry. I'm going to bring in an external private company to manage those towers for me. And I'm going to share the facilities on those towers with other tenants that private tower company organizes. So there's some examples of private tower companies here. This within the telecommunications industry is often known as delayering, where effectively multiple tower estates are consolidated into one and a tower company helps do that. Sometimes the tower companies are pure private companies, sometimes they're joint ventures between a number of mobile operators. That does bring the benefits of the private sector to the party as such. In some instances, the towercos themselves raise the finance to actually build out and improve the infrastructure. That may be attractive to an rail infrastructure manager, for example, for someone else to finance a build out. Question here relating to safety. Are the towercos trusted to work trackside? Now, we come back here to the safety culture, and I think we've sort of, the implication here is that if you're doing passive sharing, then by and large, you're not so concerned about the safety cultures within the two organizations, because the rail undertaking, of course, is responsible for the safety aspects of its telecommunications network. We've only got passive sharing going on here, which does have some interference implications, but they're nowhere near as bad or as unmanageable or as potentially complex as the active sharing and network slicing, for example. And often, in many cases, actually, the towercos employ subcontractors who are already working trackside anyway. So that's, in many ways, is a question that can easily be managed. Okay. Another option, and this is where we really start moving into, can we turn this into a profit center? What happens if the rail infrastructure manager rents the space directly to the MNOs? Doesn't involve a third-party company, but actually rents it itself. Here we start seeing rail infrastructure managers actually generating profit from the assets. Obviously, those assets need to be upgraded such that they're suitable for MNOs to rent. So, for example, they may need additional shelter space at the bottom of the tower. They may need different structures and masts so that you can have multiple antennas at the top of the mast. That's something that needs to be looked at. You could adopt a neutral host type approach where you have one entity within the shelter at the bottom of the tower that services multiple mobile operators. That could be a sensible way to do it. But the critical question that you have to ask when you're thinking about this is, will MNOs actually pay to provide coverage to the traveling public? Because if you're cynical, you could look at this and you could say, well, the MNOs have got away for the last 30 years without providing the traveling public with good coverage on trains. Why will they change their minds and provide that now? Why will they come and take space on trackside towers? Maybe they'll do it in certain areas, but why would they do that across the network? They may indeed not. in which case you're left with a situation where you may have expended a lot of expenditure on new facilities, and the MNOs don't actually take it. So that's something to bear in mind when you're looking at this particular option. Okay. Another option for monetizing the spectrum is another option to monetize FRMCS is to look at monetizing unused spectrum. It's very interesting that the band that's being proposed for FRMCS, 10 megahertz in the N39 band, is actually prime spectrum. And what's more, most devices and base stations are equipped to operate in that spectrum somewhere in the world today. So normally it's just a case of switching it on within the devices themselves. Now that could mean that it's a very attractive option for MNOs who are short of spectrum in dense urban areas to actually rent this spectrum if it's permissible under the license terms for the spectrum on a short-term basis from the rail infrastructure managers. So, for example, if you think about a dense city centre area where there are no rail stations, then in that narrow geography, it may well be possible to rent this spectrum to a mobile operator, once again generating income for the infrastructure manager. And as I said, the critical benefit of the interest in this spectrum is that the devices and base stations are already configured to use it in some place or another. Okay. Another very interesting option, which we cover, option 6, which we think is novel, and we've not heard anyone propose anything similar to this before, is that as a government, you could look at this and you could say, well, I'm going to I'm going to issue a new MNO license, a new license along with some spectrum to a party who commits to solve the public communication issue of providing mobile communications along the rail track. And in addition to doing that, so I'm going to give them some spectrum to offer a public mobile telecommunication service. And in addition to that, the condition of the license is that you will provide passive infrastructure sharing to the rail infrastructure manager for them to operate their FRMCS service. So effectively, you're going to the private sector and you're saying, well, we've got this social problem of not being able to provide or not having good mobile coverage along the track. So if I'll offer you this license, if you solve a problem that I have, which is basically upgrading the passive infrastructure along the tracks such that I can basically install FRMCS. So that's a novel approach. The way that this would work to the traveling public is that they, for example, when they get their ticket, would have an eSIM printed on the QR code, printed on the back of the ticket, which would enable them to use their phone for example, data connectivity along the track on their journey. Another way for the private sector entity, which we've novelly called Rail Roam here, another way for them to generate income would be to do national roaming agreements with existing MNOs. So effectively, if the MNO wanted coverage for their customers along the track, they could enter some form of deal with Rail Roam, a few million, tens of millions, hundreds of millions a year, whatever it is, to give the MNO customers coverage on the track. So we can see that that's a possibility. And it would certainly meet the strong desire for public communications from the travelling public. And as I say, I think this is a novel approach. I've not heard anyone propose anything of this nature before. It will, of course, require the motivation of government. But once again, the government is the public paymaster, and one assumes that they would be motivated here to both solve a public communication problem and a problem that they have, which is funding this upgrade. Option 10, which is not actually in the white paper, this one has come to us since we've written the white paper. But it should fit in this flow of the presentation, I think, which is the flowing through of costs through the value system, through the rail value system. So, for example, infrastructure managers who are likely to be bearing the cost of this deployment could say, well, what have I got here? What new services am I going to be able to sell to railway undertakings? And then those railway undertakings passing that cost on ultimately to the travelling public. Now, an example of this could be that the infrastructure managers charge the rail undertakings for a bearer service that enables the real-time monitoring of engine performance data on the trains. So yeah, that could be a typical example. There are many, many others, of course. But a more fundamental question here, of course, is are fare increases without service improvements acceptable to the travelling public? Because it's the travelling public here in this option that's ultimately paying. And an area where I wouldn't claim at all to have any expertise is over the legal framework between the infrastructure managers and the railway undertakings. Can they actually pass a charge like this on? And that may well be different in different countries. As I say, I'm no expert on that, but this has been put forward as an option. I'm personally not sure that the services that an infrastructure manager could provide to a railway undertaking are significant enough to cover the upgrade cost of FRMCS, because remember, as much as anything, this is a technology upgrade that's required because GSM-R is a 2G service and is going obsolete. So, you know, if that service is included today in the deal between the infrastructure manager and the railway undertaking, I'm not sure quite whether that would be permissible. But that's a question that's really beyond my expertise. There may be others who have much more expertise on that. Okay, another option which doesn't really address the option of turning it into a profit center, but on the other hand, it's still a very interesting option that many may ask about, well, could we make it simpler? Can we reduce the overall cost of this thing? And that leads us to think about the blanket requirements for FRMCS and whether they're appropriate. And what I mean by that is, do we have the same requirements on a fast high-speed main line? Are those requirements the same for a local line which may only have 1 or 2 trains a day? You know, do we have to provide the same level of FRMCS service, question mark? And that may lead us to think, well, there are companies out there that produce solutions called 5G in a box, and I've just named a few above here. They produce solutions that, you know, we could deploy on a local line that perhaps don't cost as much as a tier 1 infrastructure vendor. Equipment perhaps is less expensive. If we go down that route, then we need to think about really the total cost of ownership. You know, is it cheaper in the long run to deploy a less expensive piece of infrastructure when we may have different support costs? You know, we'd have to have 2 spares holdings, we'd have to have 2 lots of people trained up, etc. You know, what's the total cost of ownership? That's a calculation that needs to be done. I don't know the answer to that at the moment. I don't have an opinion on it. I just know that there are solutions out there that at least advertise themselves as being less expensive than a tier 1 solution. What I would observe here is that from a government policy perspective, it doesn't make sense to have one blanket FRMCS requirement across the whole of a network. It would be sensible to have different requirements for different types of line. But I would say that when making that type of decision over different levels of requirement, it absolutely makes sense to ensure that those requirements are synchronized across the deployment geography. In other words, across anywhere where there's FRMCS deployed, because the last thing you want to do is to have a different level of service in one country to another country, because that will then mean that the economies of scale are distorted or disrupted for the infrastructure vendors. Yeah, infrastructure vendors need to ensure that they're producing one common type of infrastructure with different grades of service, but not different grades of service for different countries, because that will end up with so many different combinations and permutations, it immediately starts becoming expensive. So that's just something to bear in mind when thinking about how to make it simpler. Okay, another option. Well, why don't we stretch the life of GSM-R? And I mean, I think looking at this, you know, from a telecommunications and rail industry perspective, in my view, there's absolutely nothing that the telecommunications industry can teach the rail industry about asset, you know, extension and asset life utilization. And to give you a good example of this, I often quote the PAR signal box, which, if I'm right in my quotation here, is the was when it was retired, it was the oldest still serving passenger rail signal box in the UK. Apparently, there is an older non-passenger rail signal box somewhere in the UK, but apparently this was the oldest passenger rail box, retired after 144 years of service. I mean, the telecommunications industry isn't really 144 years old, and certainly we're not using any of Marconi's equipment, you know, his original spark gap equipment today in the telecoms industry. Absolutely none of it. This is a risk versus economics question, of course. The risk being that will the rail networks, is it politically acceptable to use what amounts to safety critical equipment where there is no support for any manufacturer, where a manufacturer has said, hey, it's end of life, I'm not supporting it anymore? I don't know the answer to that, but I do know that it costs to upgrade. We also come then in this point here about the idea of physically migrating infrastructure around the network. That's a way of extending the life of GSM-R. In other words, we say, well, I'm going to do this type of track first, and I'm going to take any of the retired equipment out from that track and use it elsewhere within the network for a period of time. But ultimately, you do get to this point is, you know, when is enough enough? When can I no longer use this? And that, once again, is a question, and it may well have a different answer in different countries, for example. Which leads us neatly to the next option, and we're heading towards the end of the various options that we have here, which is, so, well, what's my existing GSM-R equipment worth? And this is a very interesting question, actually, because it's likely to be worth a lot more than you think. And there's likely to be some potentially likely to be increases in the value of GSM-R equipment over the next sort of 5 to 10 years, depending on how people take the equipment out of service and how they use it. One option is for a rail organization to, as I've mentioned before, have a planned migration of equipment off certain lines onto other lines. So you're effectively extending the life of the GSM-R equipment. Another option could be to take the equipment and simply sell it to others, and that has some major advantages. It's a source of income for the equipment. You know, you can recover costs on it. The other issue, of course, is that you then no longer have to account for the environmental carbon footprint impact of basically scrapping equipment, decommissioning it. If you're selling it, you're not scrapping it. You're not carrying the carbon decommission at that point. So those are factors that basically could lead you to think, well, when do I sell this equipment? When do I take it out? Because, of course, if you go through the process of migrating the equipment through your rail network, the chances are you are going to be left with the carbon footprint impact at the end, and you won't get the benefit of having been able to sell the equipment. You may be able to look at this and say, well, actually, if I sell it early on, maybe it's worth more. Maybe I can maximize the recovery of the value of that equipment. Someone else wants to buy it, and I can use those funds to buy new FRMCS equipment. This is all a balancing act where you need to make a number of assumptions and come up with a sort of a plan of the best thing to do. Okay. So hopefully we've covered off during this short presentation. There are lots and lots of questions here and lots of unknowns, lots of things that need to be considered. There's no right answers here at the moment because there's so many moving parts. Over the coming years, we're going to have lots of interested parties asking lots of questions like this. Some of these questions you might say are, you know, they're daft. They don't apply in my instance. There's an obvious answer to that one. But equally, for someone else with a different set of circumstances, it could be a very germane and very important question. And likewise, there could be another 20 or 30 similar questions that we just haven't thought of yet. But I think it is the case that whenever considering any of these options, you know, we all need to try and arrive at the right answer. And the type of parameters that go into deciding what the right answer is, I think relate to safety, for sure, the safety of the traveling public. They also relate to public service. And what I mean by that is both public service in terms of transportation. Does this solution enable me to run a more efficient, more timely public transportation system? And does it also give benefits to the traveling public? Will they have a better form of communications? Is the solution cost effective, of course? Yeah. And does the solution work from a wider geographic perspective? And this is a very interesting point in relation to FRMCS, because of course, this is a system that works across geography. It doesn't just work in one country, it works in multiple countries. And a decision that may be made in one geography could actually have a knock-on implication in another geography. So we need to make sure that when we're making decisions here, that we don't sort of cause some form of externality effect of a knock-on effect in another country that we didn't quite think through, etc. And we certainly see the enormous importance of the role of the UIC in that, to sort of coordinate any of these major decisions, or at least to make people aware of what the decisions that other people are making. Okay. So how can we at Ray Castle help? I'm sure that many of you are aware that we have a whole wide range of training courses to help upskill the rail industry. There's a lot of courses there. They address GSM-R, FRMCS, both in a 4G and a 5G format. And we have a lot of 5G cell planning type courses, etc., that are focused on the rail industry. So we've made sure that the courses that we have are actually tailored to the rail industry. There's a wide range of them there, and they're available on the website. And we're introducing new courses in that area on a regular basis. But there's two new things that we're introducing that we're sort of introducing over the coming days and weeks. The first one is an FRMCS executive workshop, which is a 2-hour on-demand course that's ideal for those people who are starting to explore the business opportunity represented by FRMCS for their organization. So this is more targeted at people in the rail ecosystem rather than infrastructure managers themselves, who typically, there are other courses that we have that are more appropriate for them. But for this is as a rapid executive overview for those who are interested in understanding the area. And then coupled with that, and maybe to address in a wide-ranging format some of the questions that we've highlighted during this webinar, we've introduced an FRMCS executive workshop, which is more of a consulting exercise, a consulting study, to actually help you understand and address some of the questions that may be relevant to you and relevant in your particular environment. For more information on any of these, you're welcome to reach out to us at consulting@raycastle.com. Okay, Paul, I'm now going to move over to question and answer. And to be fair, I've not been looking at the chat, so maybe if you want to highlight to me whether there are any particular questions at this point, or whether anyone wishes to add some. Okay.
Yes, there are a few questions in there.
Okay, let me have a look. Right, first question here. How can you operate effectively in a spectrum that may differ from region to region, interoperability across different networks and borders, etc.? Well, the idea of FRMCS is that the spectrum that would be allocated would be broadly coordinated. This is really a topic a question that is addressed to the wider spectrum management community, not just to FRMCS. And radio equipment, base stations, and handsets have for many years been operating on different bands and operating together. But I do take your point, because if you're moving in a handoff type arrangement and you've got big differences in spectrum, particularly if you're moving from something that's radically different, for example, the 900 band to the 1900 band, those are very different. So that all needs to be synchronized. And I guess within the realms of possibilities, that's one of the things that the Moran 2 project is looking at, is how does this all work in the context of what we know at the moment. So I'm hoping that goes some way to address that question. Let's look at the next one. Hold on. Gradual transition details. Right, yes, okay, right, that's a very, very good question. And it's one of the things that I have often talked about. It's not really relevant to the financing of FRMCS, but the industry is moving to a point where there's going to need to be interworking between GSM-R and FRMCS. This is not a knife switch transition. It's going to be a gradual transition, as you point out. And there's a whole lot of work that needs to be done on things like interworking, interference, working together. There's an enormous amount of that. And that's before you start thinking about the practical issues of how do I upgrade this tower whilst there may be trains in service? How do I install a new tower along the track when there's trains in service? Or, do I stop the track? How do I do it? How long's that going to take? How many teams can I have deploying new towers, etc., and all of the practical implications of that. How do I do it? And that's a whole different subject that we also know a lot about, but it's really beyond the scope of this particular webinar. If you want to talk to us about that, reach out and have a chat. There's a whole lot of exciting things that the telecommunications industry has learned on that topic that are applicable to the rail industry. Not least of which, for those of you that know, are things like screw pylons and things like that. Anyway, how attractive would it be for considering the need? Right, I don't think I fully understand the question there. So maybe if the person who asked it could rephrase it. How attractive would option 8 and 9 be, considering the need of the GOA4? You're gonna have to explain that question a bit more to me, I'm afraid.
Hello.
Hi.
Yeah, I was referring to the option that the extensions of the GSM-R, and considering that it is talked a lot about the grade of automation for which the train needs and how much it would be supported still with the current, let's say, infrastructure and solution from GSM-R, rather than in the need of FRMCS, because you listed all of the options, and among those were also these the extension of GSM-R.
So I think your point is, your point, could we try and extend GSM-R for 144 years? Is that the point?
Yeah.
Okay.
Would it be relevant to, I mean, because your point, you are listing the various options, and it should also be seen, would this be attractive or relevant for a longer period of time, the extension of GSM-R?
Yeah. So look, the issue, I guess, with GSM-R is there's going to come a point where the manufacturers and vendors of GSM-R are going to say, we're not supporting it anymore, right? And they've already started indicating when their last, their life cycle is. Basically, they've pre-announced it. It's not coming as a surprise. So you can run up to that date, no problem at all, and there's going to be a level of support up to that date. When you go past that date, you're basically ending up in, shall I say, the Windows 95 issue, right? Where you've got equipment that gradually is getting out of date and out of date and out of date. Any security vulnerabilities that are found in that equipment at a later stage are not going to be being patched. They're there. It is known that there are cyber vulnerabilities with GSM-R. I'm not going to go into any of the details of that, but there are issues, and this is common with GSM 2G, but none of them are going to be patched. Now, you may say, do you know what? I can live with that. It's okay. I can, for what I'm doing in my deployment, I can live with it. That's fine. But you as a public organization and the politicians that are behind it, etc., are now taking that risk, right? And maybe it's acceptable. It's, once again, it is a risk economics equation. The issue, I guess I would say, is that I wouldn't want to be on the end of I wouldn't want to be the PR manager who has to handle, the fallout of any incident that happened when it was found out that I as a public servant or government were running things that were known to be out of date. That's a sort of the dilemma that you're in. How long can the life be squeezed out of it? Can it be squeezed out 144 years? No, I don't think it can. Can it be squeezed out for a period of time? Yeah, it probably could be. But I don't think, if you're a large European country, running a high-speed rail network, and trains are going across your geography, and they come into you using FRMCS and they leave you using FRMCS, I don't think that anyone else within the community is going to be terribly happy if you say, no, I'm not interested in FRMCS, I'm running just GSM-R on the fast lines, because I don't think that works, and it's not really in the spirit of things. So I don't know if that addresses your question, but it goes some way to it. Then move on to the next one. GSM-R is still in operation during the transition period. Yep, certainly will be, and it has to be. will there be a complete switch due to regional developments? Well, I think that governments are making decisions on that now. And yes, one of those things that will be a continuing, but there's definitely a need for migration. And one of the things that we've spoken about and promoted is the need to ensure that you have people trained and within the infrastructure managers, that you have people trained on GSM-R, you understand GSM-R, because you're going to need to be working with it. And it's one of those things whereas when it was originally introduced, there were lots of people in the industry that understood GSM-R. As it's gone into operation and many of those people have retired and left the industry, then there's slightly less active knowledge of GSM-R. But now we come to a migration, we're probably going to need to rebuild that knowledge so we can, we understand how it works and how it can be effectively migrated. So there's definitely a need there. Now, with regards to option 6, has there been any consultation on this to gauge interest and viability? As I said, option 6 is a novel option, and I think I've not heard anyone promote anything of this sort. But what I would say is there's some very, very interesting precedent within another part of the mobile telecommunications industry on a European level about 10, 15 years ago to do something very similar to this in a different context. And I'm very happy to discuss that. I know the person has asked the question here. I'm happy to discuss that, with anyone indeed after this webinar. But there's some quite interesting precedents there, and it may well be it's one of these things where let's just say that you did get into a circumstance where you had space that you wanted to rent along your track. Then you could start a consultation on doing something else that might simply encourage others to rent that space, and then you no longer need to do option 6. But that's a different issue. Okay, another question here. Effective and enhanced, right. Mustafa, I don't quite understand your question. Perhaps you could, if you're able to ask it yourself, are you able to turn your microphone on and perhaps ask the question?
Sir, we are talking about the FRMCS, that it's a new technology and it gets some effectivity. And also due to, if we describe with the GSM-R, we can say that we have a chance in real-time monitoring, predictive in maintenance, automatic train operators, and other new technologies that we can talk about it.
Yes, so here's the thing, I guess. GSM-R is based on 2G. And I remember many, many years ago when I worked for Motorola, and I'm sure many of you may even remember carrying around old Motorola handsets that you plugged into your laptop and managed to get to go at either 4800 baud or 9600 baud to try and connect to some, a modem at your place of work. It was really slow, wasn't it? There wasn't a lot of data, and you were lucky if you could get it to work. But it was the leading technology at that time, and was quite a marvel, actually, that you could plug your mobile phone in and get data connectivity. GSM-R is based on 2G. It's like that, okay? FRMCS is based on 5G, and it's like having a broadband connection on your laptop. In other words, there's a lot more data that can be moved over the bearer, right? So FRMCS gives you the possibility of introducing the type of technical solutions that you mention here. It gives you the ability to introduce real-time engine monitoring. It gives you the ability to introduce predictive maintenance. In itself, those are applications which effectively are above the data bearer. They require other things within the environment. They require sensors on the train itself that are connected to the so-called TOBA architecture that go back to a monitoring solution where you have some intelligence. So they're, if you like, add-on things that need to be added, but they're all possible. They can be done. I'm certainly not an expert on what you need to measure, to work out how efficient a train engine is operating. But what I would say as a casual observer is if you look at the airline industry and the way that the airline industry has moved, engine manufacturers like Rolls-Royce no longer sell their engines to airlines. They sort of rent them on an hours used basis. And Rolls-Royce are responsible for taking data in real time off the aircraft engines, somehow transporting that back to their maintenance center, and then analyzing it and predicting what needs to be done with the jet engine. Is that going to happen in the railways? I have no idea. Has it happened in the airline industry? Yes, it has. So there's lots of different options here that may come to pass. Who knows? Right. Okay. Well, we've got time for another question. I'm sure we have. Someone's just asked one here. Is there an official end date for GSM-R? I mean, do we have a defined date with GSM-R and long will be supported by manufacturers? So far, I've heard timeframes, etc. Yeah, there's two cutoff dates here. The first one is that various national governments, and I'm referring to the German government and the UK government, have announced end of service dates for commercial 2G GSM networks. Okay, and I think off the top of my head, it is mentioned in the white paper, but I think in Germany it's something like it's in the 2020s, and in the UK I think it's in 2030s, early 2030s. Now the implication of that is that once the commercial networks cease interest and cease service on the 2G networks, once they no longer are able to have a license to operate in those bands and that technology, then the vendors will withdraw support. And effectively, you're then on a rapid downhill spiral where no one is going to maintain 2G anymore. So what you're going to get then is announcements from the GSM-R industry actually either somehow working out how to extend the life of their equipment. It's going to be costly, I can only imagine, or they're going to give you firm end of life dates. And those are going to be announced, as we go forward. But it's my understanding that the infrastructure industry is looking to migrate everyone over to the latest technology, i.e. FRMCS, because of the benefits that it has, not least of which the cybersecurity benefits that are in there. Okay, hold on. And the contracts, of course, are going to be individual between individual manufacturers and the infrastructure vendors. And you've got numerous infrastructure vendors in there that everyone will know as well, if not better than I do. And if you talk about the majors here, you've got Ericsson, Nokia, Comtron, and others. But it's that type of organization. And just because one manufacturer announces an extended life, it doesn't mean to say the others will. And if you've got a mixture of equipment, that could cause you problems. Okay. Funding costs for the mobiles. The reason that I've primarily focused on the infrastructure is simply that it comes first, but you're absolutely right. This is a key difference actually between the mobile industry itself, the telecommunications industry, and the rail industry, that often in the telecoms industry, the cost of the handset is in a way borne by the customer, either through a subscription or an outright purchase. In the case of the rail industry, all of the trains and equipment are going to need to be upgraded. That is going to have a major cost and a major disruption cost. To me, the cost there is broadly going to be wrapped into the same bundle. Although I do take your point. For example, if you take option 6, there's no real benefit from option 6 to finance equipment on trains directly. That's an interesting point, actually. And it does come down to, in a way, there's actually a national government issue here as to how you might want to finance this. And if you do finance it through some form of public-private partnership, for example, which could be done in order to manage a GDP to debt ratio type issue, then that could come into that type of equation where there could be organizations that emerge to do that funding. It's a more of a sort of macroeconomic issue, but it's a sort of an issue of public debt ultimately, and how you fund public debt and the various debt caps that countries have announced. And once again, if you're really interested in that, it may be worth contacting me after the webinar. Okay, Paul, I think we've nearly run to the hour. There's probably time for one more question if anyone has one. Otherwise, I think we'll draw it to a close. And as I said, you're very welcome to contact me at consulting@raycastle.com or any other member of the team. Paul, do you want to take it back to wrap it up?
Yeah, thank you, Andrew, and thank you everyone for attending. Hope you all found that as interesting as I did. Great to see so many questions as well. It's always good when these sessions are interactive. Just a reminder that we will be sending a copy of the recording of the webinar and a copy of the accompanying white paper over to you, probably at some point tomorrow, so look out for that in your inbox. Our next webinar we've got scheduled on the rail industry is same time next week, where we'll be exploring the latest FRMCS updates with the release of the new V2 specifications. So I'll include a link for that webinar in the follow-up email as well, so please look out for that. But yeah, just once again, thanks for all attending a really, really good, lively session.
Thank you, everyone, and look forward to hearing from you.
Thank you.